Parseval's identity for Fourier transform to the function f of x and show integral 0 to infinity sine square ax by x square dx is equal to pi a by 2. So what is Parseval's identity for Fourier transform? Parseval's identity for Fourier transform is, first let me write the Parseval's identity, integral minus infinity to infinity f of x the whole square dx is equal to 1 by 2 pi integral minus infinity to infinity capital F of s the whole square ds. Okay, so this is what we have to do. First, let me do the LHS. So what is my LHS? Integral minus infinity to infinity modulus of f of x the whole square dx. Okay, so now what is f of x? F of x is given in the question. So in the question, what is f of x given as? F of x is equal to 1 for modulus of x less than a and 0 for modulus of x greater than a. Okay, so first let me sort out this first. Here the integral is minus infinity to infinity, but here the interval is different. Okay, so first modulus of x less than a is the first part, modulus of x greater than a is the second part. Okay, so what is the meaning of modulus of x? It is plus x less than a minus x less than a. Similarly here, plus x greater than a and minus x greater than a. Okay, so what I will do here, plus x greater than a, I will keep it as such, whereas plus x less than a, I will keep it as such, whereas minus x less than a, I will change it as x greater than minus a. Both means the same. Okay, likewise here, plus x greater than a, I will keep it as such, whereas minus x greater than a, I will write it as x less than minus a. Now I draw the diagram. So what is the limit in the formula? The limit in the formula is minus infinity to infinity. I mark a center point 0, fine. Then I mark 2 points minus a and plus a. Okay, for x less than a and x greater than minus a. So where is x less than a? Less than a is this full part, whereas x greater than minus a is from here. So this part, my f of x is 1. Okay, now consider this for x greater than a. So x greater than a, my f of x is 0 and x less than minus a also my f of x is 0, which means for this particular function my f of x is 1 and for this particular part my f of x is 0. Yes, now can I rewrite the limit? The limit can be written as minus infinity to minus a plus minus a till plus a, the function is same. So minus a to plus a to infinity. Okay, so this is f of x the whole square dx. This f of x the whole square dx, and this is modulus of f of x the whole square dx. We clearly know this minus infinity to minus a, the function is 0. Likewise, plus a to infinity also, the function is 0. So what is remaining? Integral minus a to a modulus of f of x the whole square dx. Okay, so for minus a to a, look at the diagram and tell me minus a to a, what is f of x? F of x is 1. So minus a to a 1. Modulus means the positive part. So 1 the whole square dx. Now when I integrate this, okay, so 1 into 1 is 1. So when I integrate 1, I will get x, because here 1 into 1 is going to be 1, okay, and the limit is a minus a. Now when I substitute the upper limit, I will get a minus of minus a, which is equal to 2a. Okay, so from this we understand that the LHS, which is integral minus infinity to infinity f of x the whole square dx is equal to 2a. Okay, so we are done with the LHS. Fine. Now we will go to the RHS. So what is my RHS? My RHS is 1 by 2 pi integral minus infinity to infinity modulus of f of s the whole square ds. Okay, so first what I should do, I should find out f of s. So how do I find out f of s? F of s is equal to integral minus infinity to infinity f of x e to the power I sin x dx. So what is this? This is Fourier transform formula. Fine. Now we have already derived from this diagram that the function exists only for minus a to a, and that value is 1. Okay. So how will this limit change? This limit will change as minus infinity to minus a f of x e to the power isx dx plus minus a to a f of x e to the power isx dx plus integral a to infinity f of x e to the power isx dx. Okay, so if you look at the diagram, this part f of x is 0, for this part f of x is 1, and for this part f of x is 0. So what is left over? It is minus a to a 1 into e to the power isx dx. Okay, so when I integrate e to the power isx, what I will get? If I have e to the power ax, when I integrate, I will get e to the power ax by a. Fine. So here it is e to the power isx by is. The limit is a and minus a. Fine. So let me substitute the limit. E to the power isa minus e to the power isa into minus a by is, which is written as e to the power isa minus e to the power minus isa by is. Clear? How is e to the power isa written? E to the power isa is written as cos sa plus I sin sa. Fine. Similarly, how is e to the power minus isa written? Cos sa minus I sin sa by is. Okay, so it is cos sa plus I sin sa minus cos sa plus I sin sa. So what happens? Cos SA and minus cos SA gets cancelled. So what is left over? 2I sin SA, because I have 2 times I sin SA by IS. So I will get cancelled. So my f of s will be 2 sin SA by yes. Okay. So what is my RHS? My RHS is 1 by 2 pi integral minus infinity to infinity f of s the whole square ds. Okay, so is there any limit specified for f of s? No, so the limit will be minus infinity to infinity throughout because no limit is specified for f of s. Only for f of x, the limit is specified. So 1 by 2 pi minus infinity to infinity. What is f of s? 2 sine yes a by yes the whole square ds. Okay, so how this becomes 1 by 2 pi integral minus infinity to infinity. 2 into 2 is 4 sine square yes a by s square. Yes, so this is my RHS. So now what do? I equate my LHS is equal to RHS, which is my Parseval's identity. Okay, so what is my LHS? This is my LHS. I mark this as 1. Okay, this is the value is 2a. Fine. So 2a is equal to, this is my 2. Okay, so what is that? LHS is 2a. What is my RHS? 1 by 2 pi integral minus infinity to infinity 4 sine square s a by s square ds. Okay, so now let's simplify this. This 2 and this 2 gets cancelled. Okay, so let us simplify this further. Integral minus infinity to infinity 2 sine square sa by s square is equal to pi into a to a. Fine. Further, integral minus infinity to infinity sine square s a by s square is equal to pi into 2a. This 2 comes down by 2, so it is equal to pi a. Fine. Now, since the interval is minus infinity to infinity, I will check whether the function is even or odd. Okay, even or odd. So what is the function? The function is sine square sa by s square. Okay, sine square sa by s square ds. I'm sorry, ds. Okay, so sine square is definitely even. Okay, my sine is odd, so odd into odd. Okay, odd into odd is going to be even, so even by even is going to be even again. So what happens, since the function is an even function, I can write it as twice 0 to infinity sine square as by s square ds is equal to pi a. Okay, which can be further simplified as integral 0 to infinity sine square as by s square ds is equal to pi a by 2. Okay, so what should I find out? Look at the question. In the question it is integral 0 to infinity sine square ax by x square dx is equal to pi by 2. I've almost derived the solution, but there is a small change. What should I evaluate? The question is, I should evaluate integral 0 to infinity sine square ax by x square dx is equal to pi a by 2. See, compare and see. Instead of yes here, I have x. Okay, so what I will do? I will put s is equal to x. Similarly, ds is equal to dx. So what will happen? Integral 0 to infinity sine square ax by x square dx is equal to pi a by 2. So we have found out the answer. Okay, you have any doubts? You can ask me.